You guys give a really warm applause to Sam. Warm applause.
Tool. I think it's very expensive. And so I've been learning Python in the meantime. But I still think it's a tool that's going to stick around for a while, just like Linux didn't really take anybody out. I don't think Python R necessarily will either. And for all the legacy systems here, it's going to be around for a while. But nonetheless, I think it's a very useful tool. And maybe in a year, I'll change my mind, though, when I get more familiar with Python. So let's see here. I guess I'll say part of this relates to if you guys know Paul Schreiner, who's actually running behind, but he works with Audience Point. I did some deep dive contract work for him relating to one of his clients. This is essentially a primer, though, but I'll show you some of the final, or portion of the final results. So anytime you have questions, just let me know. I'll stop whenever. All right, so SAS is a 50-year-old language, or 51. So it's kind of amazing it's been around that long, but it was recently, well, somewhat recently, rewritten in C in 1985. And as far as for National Data Corp, it's a pretty large percentage compared to for the business analytics software. So Oracle leads and SAS and trails off after that. I know the two founders are each worth about $9 billion of SAS. And quick story, at East Carolina University, there was the third guy that was going to do it with them that didn't. And he was where I was tenured, so unfortunate for him. But it's a good system. So I'm looking at SAS now as far as I'm looking at Python. So you probably know Birchworks. If you don't, they do some data science survey stuff. And so this is through time how SAS has declined. This isn't a real structure. It's not a well-structured test, not at all. Essentially, last year, Python was written in. And they had so many people writing in saying Python is what they use for data science tools, they added Python. But you can clearly see that SAS is a growing share of the data science world, but the data science world is getting larger at the same time too. So I still think there's a lot of opportunities out there. And I wouldn't interpret this necessarily as R getting smaller. It's just that Python came to the story. All right, so as I look at Python compared to R, so SAS is not case sensitive, which I love, but many other programs are, and it kills me because I've never learned any consistency in my programming. So in my background, I learned Fortran back in 1999 just to pull data, and I learned SAS, and other than that, I've learned nothing. So SAS index starts at 1.0. SAS uses the hard drive. It just doesn't take everything RAM. It typically uses the hard drive, and I've worn out many hard drives that way. But for larger data sets, if you have restrictions, that's the case. It'll work for you. SAS has an interface that's kind of nice. At least I believe it's nice, but I've spent 15 years looking at it. So here's an example where you have the log where the code will run through. It'll give you a time of the process time. Any errors will come in, it'll give a different color. You have your coding in this section. We'll talk about certain sections of this. You can have your results. It'll show on this tab. And so it'll, whatever you run in particular. And pretty much any statistical analysis you want to do, SAS will have. Now, sometimes SAS is behind in the development of them, I've noticed. A lot of my programmer friends and I use Stata instead for that, but because of the timing of it, but it's quite a nice package. And as far as the tables, all right, so it'll generate temporary files that you look at each step, and then if you want permanent files, I'll show you how that's created as well. All right, so to summarize, SAS is going to stick around for a while, but it's certainly losing market share. And if you're used to it as a procedural language, it's very useful. Here's the interface. All right, so I'm just going to talk about a couple things about just a broad overview of what the steps I'll take to do a certain project. All right, so the lib name, I'm just going to read in the file. I'll just tell the file location. I'll assign a name to it. And typically what's commonly read in can be CSV, but it has a large range of options. And you can pull for 10 or 12 different folders, of course, it doesn't matter, and combine all the data for your analysis. Now, I don't know if you can see, but these are the ones for the auto import that they automatically have. So Excel, XS, CSV is the one most commonly used. You can use text. They even have Lotus down here just in case you have some old files to bring in. And there's other interfaces as well that SAS will access to. SAS is trying to become more friendly with the open source world. It actually has the ability to put Python and R code within the SAS code as well. So you see Lotus, you know it's old school, but at the same time it is trying to keep up with the ages. All right. A benefit of this as well is if you do the auto import, it'll actually give you the code as well. So let's say we want to do a code. Let's just look at this first one here. These two are exactly the same except for this one piece right here. All right? So I want to note when you import a file or anytime you use a file, it's a temporary file unless you sign a particular path. All right? So it has a work folder or any file created is only there as long as you keep that SAS session open. Once you close that, those temporary files go away. So that's good and it's bad. I'll tell you a hint though, if your computer automatically shuts down, it does save them, but you have to dig through the SAS temporary files to find that path and pull them out. But many times I've had programs run for hours, the computer shuts down, and you lose your work. But you don't actually lose it if you can find it in the temporary folder. All right? So the only difference here is this raw path, and that's just assigned to a folder. If I assign a particular folder, the file becomes permanent. Any questions so far? And feel free to say things because I know I'm only familiar with SAS. So I don't know how familiar you guys might be with this also. So I see a few smiles. So I'll comment as far as the data row. Data begins in a second. You get the names. In other words, it pulls the column identifiers for the project, for the files. And that's it. So what I really like about SAS is every single data step, I have easy access to the new data created. Right? So when I set in the before data, so this is what before it's actually run, you have the before and you have the after. And then what happens in this transition between the set and the data stage is whatever you have take place. You can have within this multiple, you can have arrays, do loops, any sort of calculation, any sort of adjustment, all the usual substring or other adjustments that you might have for identifying data or restructuring it or whatever you used to do is available in this section. So you can see the data before and after. All the data typically ends with a semicolon. So I say colons are rare, but semicolons are everywhere. And if you ever mess up and hit colon instead of semicolon, it won't always easily identify where the error is, but you won't always see where that error. So it's I've wasted much time doing that. Then the indentions that take place don't have to do anything with the code. There's no lines like Fortran, that has to be in a particular place. Essentially, the indentation just so you can more easily see it, which is common in coding. So now let's talk about macros. So macros make it very nice to regularly repeat certain coding. So in this case, with audience support, I had about 15 of these files to take place in CSV format. And I brought them in, and the way they were pulled from the data before, they had extra variables, just empty columns for the double commas, and it's built an extra column for me. So the macro, I give the macro a name, I say when the macro ends, and I have any variables I want, which are represented by, it's called ampersand. This symbol here is the variable that will fit in. So I name any variables that are going to exist and used within that macro. And when I call the macro here, so I have macro raw clean, and then I import name. In this case, I say it's audience point bestsellers.csv, and so it'll put it here and carry it here too. And I should note, I'm sorry, on that last data step, you don't have to have a different name every time. Right? It'll load the program data vector and rebuild it again, and you can use the same name every single time. The problem with that is if you have an error somewhere along the way, it's hard to identify where that error took place. Right? And by I mean an error in that case, not that you programmed it wrong, it did what you asked it to. So in this case, I have the start and end of the macro, then the various versions that I want to do so I can quickly run through. It makes things very nice. You can do macros inside of macros inside of macros. There's no limitation on the structure of what you wish to have inside this as far as data step, arrays, do loops, regressions, anything you can do in this section. So commonly if I have to do a particular visualization, and you'll see in a minute I do some on 5-minute buckets. If I want to do them on 10 minutes or 15 minutes or 1 hour, whatever the case, then I'll just have one of the variables I select, which may be in some cases 10 or 12 variables. Just one of those variables are altered, and then the output name will be altered as well. So let me ask, what are macros called in Python? Do they have a symbol like this? Standard function? Okay. Well, only thing I'm copy and pasting maybe is the, when it compiles it. Okay, yeah, I understand. Okay. All right, so another benefit of SAS is when I'm merging or stacking the data. All right, so it's very straightforward. Ironically, it makes you sort the data first. Some of the merging procedures I've seen, you don't require the sorting the data. But sorting the data by a particular variable, then you just merge. You can merge any number of data sets by any number of variables. Sometimes you'll merge by, I've had to merge by 3 or 4 variables to keep things identified for a certain data pattern that might take place. So if I want repeat opens clicks, again, it's audience point, so merge repeat opens, repeat clicks, individual email event ID, and so it creates this data set based on combining these two when they match on this variable. All right, so for me, that seems very clean and very straightforward. If, let's say you have multiple data sets like I did with this import here. So I have all these data sets created, and let's say I just want to have them all combined easily. There's no requirement other than just to stack them. So if I simply list any data sets I have, they automatically stack them on top of each other and give me the merged, well, it's not merged data, but the stacked data. Very clean, very easy, and pretty fast. All right. I should note, well, I'll note this in a minute. Any questions on school? All right, now, I've been looking at lags in Python, and lags in Python seem much more difficult than they need to be. Maybe I'm missing an easy step based on the Stack Overflow stuff or whatever I looked at before. But data lags, so if you look at the previous variable in any row, all you have to do is sort based on a particular variable. In this case, descending on this variable, you can either sort it upwards or downwards, highest or lowest, lowest to highest. Right? So you need to get in a particular order. So if you have your string of data and you want to see what happened previously, to see a change between 2 data points 2 times, right? Then all you have to do is just do lag 1, lag 2, lag 250 if you have 250 days, or lag 365 if you have daily and we do annual, or the case might be. And it creates another column, right? You don't have to name it lag 1, lag 2, but it's consistent to do so, right? So you can more easily identify the variables. But if you want to see any prior activity, the lag's very smooth, very easy. And if you want to do both before and after, so you could do this, and you just take away the descending, do it the other direction, and then you lag again. Then you'd have the transaction that happens, this ID, and then you'd have the before and after, all in the same column. So if you want to take differences through time, or see a particular range, or see some sort of adjustment that takes place in a time period, it's very easy to do. I was going to ask before, has anyone ever used SAS? They didn't raise their hand very high. I won't point them out, though. No. Very good. Let's talk about product transpose. So sometimes you can write code to twist and turn the data, but product transpose makes it very easy. You have a particular matrix, and you want the rows to become the columns become the rows, right? You'll sort by the variable that you want it to turn on. So you sort on the 2 variables. You have the data in, the data out. So let me say this out function, it varies based on different procedures, but for me, this makes it very easy. If you're doing regression, a Pratt Logistic, you want citizen trees, or you want the centroid of certain clusters, or whatever the case, SAS pretty much always has some out or out est or out cove or out something where you can easily output the data, easily output the coefficients that are created from a particular model. So if you want to create a training model and you generate the coefficients for it, you can easily output those coefficients, and the very next step, input the data for the portion that you want to test and run those coefficients. All right, so it's very clean and smooth. So you output, and there's other things where you can adjust based on the ID or other information that you have, but in the simplest form, this is a very clean, quick way to turn the data. All right, ranking data. So if I want data to be simply ranked, well, I could use like the index that runs down the side. But let's say instead of having it simply ranked, I want to put it in particular groups of 10. So I have 1,000, I want groups of 10. There's certain easy ways I can do it, but if it's not a round number, you want it automated, and the numbers adjust based on the different things you're running through the program. This is a very nice automation way to do it. Taking your data, it'll output the data, and it'll add a column that says, well, in this case, I name what the variable was I ranked by rank. So it'll put in 10 groups. If there's a tie, it puts it to the lower group, and it quickly puts those variables that I'm ranking on to the 10 categories, 0 through 9 in this case, and allows me to analyze certain groups. So if I want to analyze in 10 groups and compare the highest to the lowest, see if there's a large statistical difference between the two based on those different categories, then I can easily do that. Or if I want to build a visualization where I put in groups and see what a certain variable changes through those groups, I can do that as well. So it makes it very convenient. All right. Now I've seen describe in Python, so you can spit out these summary statistics. This is similar in that I will spit out the ability to spit out the end, the mean, the median, the 95th percentile, 50th percentile, 75th, 25th, whatever I want to do, the sum, the number. I can output all that information. In this case, what I'm doing is I'm sorting. I want to do it based on a certain category of data, whether or not it was send time optimized, and what bucket belonged in. So I can sort across those three portions. So I could sort the entire data and get an aggregate number, or I can partition the data into 10 different groups. This is a binary 0, 1, and the bucket might have 10 different buckets. And then so I can take the means of all those different categories, which are really 10 times 2 times 10, and I can do it all at once with a step and output it this one file. And each file has that identifier for which category it came from based on those three criteria. So it gives me the ability to quickly, based on these variables, and what we're trying to do is for each bucket, we're looking at the revenue that was generated, right, the conversions that took place. So across that, in those strict categories, I can very quickly put it in those different compartments. It makes it very easy to build some sort of visualization. All right, so questions on that? For me, that's nice and handy. So let's look at creating plots. I look at like matplotlib, and there's all sorts of things I need to get used to. All right, and there's the same in SAS, the various plot functions they have. This is a straightforward one, and I'll show you a plot that was created with it. And so it's nice. Sometimes I've taken them from SAS because you can easily export to CSV, convert to Excel, and build some sort of graph there. But it's very nice to have the function within SAS to do it, so you don't have to switch back and forth. In this case, input the data that I use, and then I'm going to have, what I have is these two lines that are going to be created, all right? So one is a bucket across all send time optimization buckets. So I put them in the different categories, and I'm seeing how much send time optimization emails happened. This is the count. How many send time optimization emails happened to be in a particular bucket at a particular time. And then I can do certain adjustments for the line attributes as far as thickness, what I want to label it, etc. And then for the second, I'm doing the same thing, except this is for non-send time optimized. All right? The issue in this case, to help us understand what's happening, or why I'm looking to this, is Audience Point had a client, and it's a particular client that has a different product than what they typically work for. And so the goal was to see if they looked at this different product mix that had different level of impulsivity, had different level of customer engagement, if this send time optimization was as effective as it was in other categories. Right? Unfortunately, it wasn't. So then the test became not just did it work or not, but did send time optimization work for those sample of emails for the customers they were trying to engage in the product purchase. Right? So we have the two lines were being created. We access the label the y-axis as emails, x-axis as grouping intervals. I assign a title for the graph. I tell how many values, 1 to 12. I can do other categories as well. And of course, there's 1,000 other attributes. And when I run this, it gives me a pretty good looking table. It's good in the sense the audience point. So we have the grouping intervals here. We have 5-minute bucket, 10 minutes, 15, etc. We see that, and this is the opens for all campaigns and send to open timings. So let me explain that. So we sent the email, and the question is, how quick does it get open? Well, hopefully when the email gets sent, it's at the top of your inbox. You only have a few minutes. You see it. You click on it first. Then you probably don't get any farther in the inbox. So if the email can get there at the appropriate time, it's more likely to be open. We're likely to have more clicks and hopefully have more conversions. So in this case, we can see that, all right, we have over 80,000 versus about 30,000 that are being quickly relative to the sent time, because the sent times vary based on the customer and their past history. We see that there are a lot more emails being opened immediately. In other words, they're being placed in the email box at the appropriate time that the customer has the attention to give to that email. All right? Now, eventually, it meets, and then it pretty much tracks the whole way. All right? So in this case, you have a cumulative portion of emails that are substantially more than what actually was for the non-send time optimization email. Okay. So if I combine the importing the data, the macro, the various data steps and procedures I do, and then I build the graph, then I have the ability for this to be generated just by cycling through every time. I can generate 20 graphs, all by the same code, just by changing whatever variable I want to change. Input data, variable difference, the buckets difference. If I want to do any restriction on a particular type of data or take a portion out or want to do everything, it makes it very nice. Once I build the code once, I'm easily able to modify it. Well, I should say that in case everyone's missing SAS, there is a SAS kernel for Jupyter Notebooks too. So, although I haven't quite used it yet. So, all right. Any questions on that? All right, so in this case, we also wanted to look at, we don't always get the data about how much sales are actually converted. All right, in this case, we had that data, what sales actually took place. We always have the send times, of course, opens and clicks, and we get some data. But in this case, we had the opportunity to test a lot more data with this new customer. All right, but again, they weren't the typical customer. So a Pratt Logistic is where, unlike a regression, where you try to explain some sort of number that has any range, negative infinity, positive infinity. In this case, you're trying to explain a 0 or 1 on the left-hand side. But then you're using the variables that you have to try to explain whether or not that takes place. In other words, it's a dichotomy. It's only they bought something or they didn't. So what we're trying to see, in this case, based on the class of send time optimization, so we're classifying it across those two categories for this data, creative name, all right? There's all sorts of other things. I'm just having it put out the parameters for me. So I'm trying to explain 0, 1, when I was converted to a cell. I'm predicting on a 1. The default is actually predict 0, but the results to me are much cleaner to interpret if it's based on a 1. So I'm trying to explain the send time optimization binary, but what it has, this function here is a very neat function. So if you're familiar with logistic regression, or any regression, you get a particular coefficient to explain a variable, right? But that variable may not have a linear relationship with what you're trying to explain throughout the entire data. So with this, we could have interaction variables that take place to see how that coefficient changes at different points in the data, right? So it would explain if you had some sort of nonlinear relationship or some sort of relationship with a second variable that was highly correlated, positive or negatively, and their interaction would affect, right, convert it to a cell, but you wouldn't necessarily understand what's happening unless you break it down separately. All right? And so we look at the odds ratio. Odds ratio for Pratt Logistic is set to 1. If it's 1, there's no more likelihood or less likelihood. Higher than 1 means there's a greater percentage of something taking place. Lower than 1 means there's a lower percentage. And so we look at the synchronization, and there were other variables in this model, but if I took it out just for convenience. But you can add any set number. But for this particular variable, at these particular points, and these particular points are different minutes that took place, and I just cleared them out here because it went too far. Right? If we do that, it'll quickly tell us the relationship of how that variable changes at those various points for this particular data. So again, because I can do the macros and I can look at various variables, I can look at any analysis for any subsection of the data very easily once I've written it one time. So it makes it very convenient. And this can be done the same for regressions, probits, decision trees, clustering, whatever you want to do. All those options are there. It's just it's a nice setup. So we look at the next slide. I'll try to explain what's taking place. So in the earlier stages, we have a higher odds ratio, right, which is meaning that they're more likely to have a conversion take place, right, based on it being syntime optimized the earlier it's received, right, which makes sense, right. These are the bands for the 95% confidence interval, and you can see that they're consistent, but eventually, all right, it goes below 1.0, so you're getting some where it benefits and some where it doesn't, because 1 is the baseline in between where there's no benefit or no negative, all right? And so you get a trend here. Now, I didn't show another slide, but I'll talk about another slide because there was another variable that we said, well, let's look at, and Paul's standing back there too, so I make sure I can't say what the variable is. But the model's proprietary they use, right, for syntime optimization. There's other things that go into it. But we did this type of analysis on a different variable, one we hadn't looked at before because we didn't have the data. And it gave us a very nice picture to help us understand that there's more taking place than what we initially realized. And so my point on this is, once you set up your structure, you use the macros, you decide what variables, and you can change the variable names and logit based on the macro or whatever else. Once you adjust all that, you can do a very quick, thorough analysis on different subsections, multiple variables, different data sections, all in a very timely fashion. All right? And so that revealed to us because, you know, you can do a stepwise regression or backwards or forwards or whatever, and you can try and figure out what the key variables are, but it's not just the variables that exist by themselves. It's how that variable at particular times will change relative to another variable that can greatly affect your use of it in the analysis. So the other one I'm not showing, but it's a nice one to know, and hopefully we'll get it working into audience points' model sometime. More into their model sometime. All right. Any questions on this? And if you don't like statistics, I might have lost you a little bit. But the point is, it's very handy. Now, it's also, I think I put somewhere in there, very expensive. All right, so I hope the pricing will change with time. Otherwise, it's going to be used less and less. But we'll see. I don't know if they can survive at the current rate at which they sell products. I looked on Core because for an individual license, because I'm going to have to renew mine soon, because the university had given mine before. Anybody have a guess how much a single laptop license would be? I don't know if Core is correct, but it said $8,700, and I fell to the floor. So, all right. So, all the more reason to learn Python or R, right? Okay. Any questions about anything we looked at or anything? I'll go to the next slide here. That is the next slide. I went faster than I thought I would, so I apologize for that. All right, so anybody have any questions? I went too fast. But if you have any questions for any data science stuff, anything you're considering looking at or analyzing, or you have a particular problem, and I should note this was about 12 million emails, so it's very easily handled. I've done data sets where we've done, so in my program in the past, I've done like all stock trades that take place on a particular exchange for, let's say, a 3-month period. And it can be billions of data points. Or if you do all financial statements, or the case, it can be hundreds of thousands. The system has no problem handling that. And I know some programmers in the academic world that will use SAS to manipulate and structure the data how they want it, and then they'll take it to other systems and do their test. All right? And I know sometimes that's R, sometimes that's Stata, sometimes that's MATLAB. But all those are key things that can work together. But I think if you wanted one thing to do everything, I know SAS can do it, but of course it can't be everything to everybody. So, any questions? There's one behind you. Good.
So typically this is an open source community, and the idea would be, hey, let's go ahead and jump in. This seems like a cool tool set. Let's play around with this. I don't know about the rest of you guys, but I don't have $8,700
well,
lying around.
You can get a free license that's limited to certain things, but yeah, I understand. But at the same time, if there are certain large, like Blue Cross Blue Shield is a huge user of SAS in the area, so there are a lot of job opportunities there, but. And I will joke, Brett was desperate for speakers. No, I'm just kidding.
No, I'm sorry. I guess I should have asked the
no,
actual
okay. It
question.
hurt, man. It hurt, but it's okay. It'll be all right,
So, for someone who I know there's several people in here that are mathematicians. There's people that would be interested in learning more about statistical applications and modeling. What would be an appropriate tool set that a say a student budget would be able to use?
Well, see, what I would like for you to say is, I'd like to learn SAS. Please teach me Python and R, And so we could exchange that knowledge. I agree that the open source, and the Python and R are the better choices. As far as, I don't know of anything, and I haven't heard any of my academic friends who do up-to-date research say that, oh man, I can't do it in SAS, I can't do it in R, I can't do it in Python, but I will say there are a couple things that they say, well, I can't do it in SAS, I'll do it in Stata. And that's even come up actually. So, I hate to stand up here and say that I've spent 15 years on a programming language, that I can, do it lovely and everything. That may be dying, and that's difficult. So I have to make sure, and I'm sure if you haven't someday faced that, you'll face that someday, where a particular language you are very knowledgeable in. The good news is, the arrays, the do loops, a lot of this stuff is similar, but SAS is not where you want to go. But the problem is, and I've caused this problem. I made this problem worse because the university gives me these licenses. They give them to me cheap. And yes, unfortunately, I have to pay for them manually. And so then what I do when I have projects in my class, see, that wasn't a good choice for me, right? I made my students use it. And sometimes if they go to an employer that uses SAS, that's great, but I would have done a better job last 15 years to use an open source option so that it would be more applicable, yeah. Yes?
Yeah, quick. Paul Schreiner from Audience Point.
That's the Paul I was referring to, by the way.
Yeah, no, I get that.
He was late, so the things I said before don't mention to him.
So here's the question that I kind of keep coming back to, which is tool sets aside, a tool is a tool. You're taking statistics and statistical models, data science, and applying it to sort of solving problems. For someone who's sort of wanting to learn that a little bit better, where would you direct us to kind of bite into that stuff? Recognizing that a tool is just a tool, and we'd apply it to Python or SAS or whatever.
Yeah, I agree. No matter the programming language, you need to understand, the basic ANOVA, regression, probit, logit. You need to understand those basic things before any toolbox is really going to help you make any sort of data science type decision or predictive analytics. So where do I direct? See, the irony of that is that you would probably go to data camp or something else like I am and just trying to learn it. So I don't have a good answer for you there. Yeah. Unfortunately, I went to the PhD program, and so they said, all right, you go take all these statistics courses. You go do this. I took a data mining course, which is also in SAS, and I took, I guess 4 levels of econometrics where we would joke, the guy would stand up here all day and he'd transpose matrices and he'd do calculations, and he was Taiwanese, all right? So I'll tell you a story. I'm sitting between a Chinese guy and an American, and I'm in the middle, and the Taiwanese guy does all day doing this, and he turns around and goes, hara, hara, hara. And it was a full explanation. Wonderful guy. I don't mean it negatively. I'm just saying, so I turned to my friend from America and I said, what did he say? He's like, I don't know. I turned to my Chinese friend and think, oh, he'll know. Right? And he says, I don't know either. All right? So my best answer to you is absolutely immerse you in the econometrics, the numbers, so that when you speak the language, you understand the linear algebra, you understand the calculus, you understand all the statistics, the probabilities, and everything that takes place to knowing what's taking place. And if you don't know that, no matter what toolbox you use, it isn't going to be handy.
Okay.
Right? So, and after that, I would say, there's all sorts of online resources. But for learning statistics, a course here or there, I don't think it would be a bad choice at all. And that's not just my professor self-saying.
Okay. PhD program. Got it.
That's fine. Yeah, I want to imply high barrier to entry. Yeah. No, I mean, I don't think it's the case. I think the options are now much greater than what they used to be, of course.
Right.
So I think there's choices out there. But you have to know the statistics behind it, otherwise the tool won't matter.
Thank you.
My pleasure. Thank you, Paul. Well, this is one of the guys that raised their hand for SAS. So.
20 years, though.
Man, you didn't have to say that.
So for really large data sets, are you limited to the RAM on your laptop, or can you
It goes through the hard
distribute
drive.
and run it on like a bigger workstation or server?
Well, so I've looked at Python, and Python typically goes through RAM, but there are options I've seen, I don't know how to put them in place in that, where you can actually go through the hard drive. Because a lot of statistical analysis, you'll need the entire covariance matrix, for example, to do a particular analysis of how something relates to another. So the benefit with SAS is, and it had to do this when it was first created because RAM was very expensive due to hard drive space, compared to hard drive space. So, and I've actually ran through several hard drives, all the data going back and forth wears them out. But SAS, you can have, 4 gigs of RAM and use an 8 gig data set. And it'll be slow, but it can certainly do it, yeah. So I know when I was a PhD student, let's say 2003, and I was working on my thesis and my dissertation, and I had, several gigs of data, and I had I had less gig of RAM, I know, and it would run. It'd be slow, but it wouldn't prevent it from happening I'm not saying it would in Python either because of the adjustments they made, but that's the benefit of it. It can handle pretty much any data set size, and it doesn't lock up, or it rarely locks up. So.
Anybody else? All right, everybody give Sam a round of applause. Thanks, Sam.
Thank you.
Hey.